So let's talk about equations and functions. Before I go any further, let's make sure we know what they are. So if I had something like 2x plus 5, that's an expression. There's nothing for us to do with it necessarily. You know expressions, you can actually evaluate them. And here there's nothing for us to do. However, if I had an equal sign, like an equation, the word equal, so equation, so equal, that is the key difference right there. That equal sign is what makes an expression into an equation. When you have an expression over here equaling either an expression over here or just a value, a constant, in this case it was just a number. So that's how you know you're working with equations. So now an equation that has only one variable, just for example this one just has x, it's just a regular equation. However, as soon as we change and maybe we add another variable, for example a completely different one, y and x, okay? Now these two variables, these two quantities, y and x, they relate to each other. They somehow affect each other. And what one is will affect what the other one is, so they now relate. So the idea of them relating, we call that a relationship. And so the way they relate is what we're going to talk about. So, and more specifically, the only type of relationships we're going to talk about right now, and for most of 7th grade math, is we're going to talk about functions. A function is something that if you actually read what it says up here, it says one output value for each input value. What that really means is the input's usually going to be x. It means when you put something in for x, it's only going to give you one option for y. Okay? For example, if we had a function like y equals 2x minus 3. Okay? So, and I'm going to plug in some values. We'll pick one. We'll pick up an easy one. We'll try 3. When x is 3. All right, when x is 3, that means we have 2 times, but instead of x, it's now a 3. So this 3 right here got plugged into x's spot. And then we have to continue with the minus 3. So let's see what that equals. 2 times 3 is 6. 6 minus 3 is 3. So that means that equals 3. Okay, so coincidentally, when x is 3, y is also 3. That's a coincidence. Maybe don't get too confident. So let's check again. Let's try 4. When x is 4, what is y? Okay, when x is 4. So 2 times 4 gives us 8. 8 minus 3 gives us 5. So when x is 4, y is 5. So let's see. So it was only a coincidence that these two are both a 3. That was because I chose 2 times 3, which is kind of like 3 plus 3. And this says minus 3. So I didn't choose a very good example as my first one to try. So from this on out, though, they're all going to be different. But what I want you to know is, let's check, though. When we plugged in 4, okay? When we plugged in 4, is it ever 2 times 4 minus 3? Will that ever equal anything besides 5? And a lot of you are thinking, well, there's the order of operations. The order of operations tells us there's only one way to evaluate this. There's only one way to simplify this, and that's what the order of operations, meaning we have to multiply before we can subtract. So this will always equal 5. So this one input of 4 will always give you 5, nothing else. The input of 3 will always give you the output of 3. In this case, they were the same thing, coincidence. So this one input will always give you one output. That idea that every input only has one output, that's what defines a function. If one input gives you more than 2 different numbers as an output, that'll happen with certain equations and you see in Algebra 1. That means it's no longer a function, it's just a relation. That's the difference between a regular relation equation, just relations, and functions. A function, every input gives you one output. So for our purposes, let's just say every function, every input has one output. That's what it'll be for almost everything you do in 7th grade. All right, so now, let's actually go through and fulfill it and do what it says to do. And this question says, complete a function table. A function table is known as an input-output table, what I was calling it. They mean the same thing, except a function table is being specific. Hey, we're working with functions. But remember, a function is just a regular old equation. It just only has one input, one output. Anyways, create a function table for y equals 5x, then identify the domain and range. We'll get to that domain and range stuff in a minute. So what they did is for every value of x, they just chose some simple numbers. You choose these numbers. They're not mandatory. I suggest you choose little numbers. Choose things that are easy, quick, and easy to evaluate, to plug in. They go in x's spot. So 5 times instead of x, it becomes a 0, equals 0. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. Now, this one was only one step. It was just times by 5. That one was easy. The one we did over here was 2 steps. So sometimes there can be more. So just be mindful of plug in for the letter and see what it equals. We did one version of it here. There's another one here. But in each of these, you'll still notice every input has only one output. Okay, so now, when the question says identify the domain and range, before we talk about that, I want you to know there's a certain 4 words, 4 terms that all mean the same thing. Your x letter, your x variable. Your x variable will always be, I said earlier, it'll always be your input. When we do equations, especially functions, we almost always use y and x. It's just tradition. You will see other letters used where they're making a point that it doesn't have to be y and x, but usually it's y and x for simplicity. And you notice we plugged in for the x. We did not plug in for the y. The x is the input. It's the one we choose. Okay, so anyways, x is the input. X is also known as the domain. You may have figured that out down here when you saw the domain is 0, 1, 2, 3. Well, look, they just named these numbers. 0, 1, 2, 3 is referring to these numbers right here. That means the x values. So the domain will be the x values. So x is the domain, is the input. There's one other term that I want you to think of now. X is the independent variable. This may ring a bell from science class perhaps, when we talk about variables in an experiment, or maybe talk about just graphing data. X is your independent variable. If you know that these 4 terms all mean the same thing, it's almost like a vocabulary moment, you have perspective. For example, notice we chose these values for x. Granted, they did it for us in this example, but you choose those. You choose whatever you want, meaning you have freedom. You have the freedom to choose. And if you have freedom, think about it like our Independence Day, when our country declared its independence from a ruling sovereign. We wanted to have independence so we could choose, so we could have freedom. So if you have independence, you get to choose. And the things you get to choose are the inputs. You don't choose the outputs. The outputs chose themselves based on what the function said to do. So the input, we choose, that is our independent variable, and that is usually going to be x. And finally, just domain is just always going to be the x terms. Domains is going to be the input terms. Domain is going to be the independent variable terms. All 4 of these words, these terms, will be used interchangeably. They are synonyms. You'll find that in a lot of mathematics, even past Algebra 1 and into all of them. These terms all mean the same thing. So now the opposites of them. The y variable. The y variable is your output. The y variable is your range. It's called the range. And the y variable is your dependent variable. Dependent meaning you rely on someone to tell you what to do. You need someone to help you, to tell you what you are. Meaning we did not know y until we chose x and plugged it in. Y depended on the value of x and then the process, the actual function, the process to take place. And that's how we found out what y was. Okay, so that's just talking about inputs, outputs, domains, ranges, vocabulary moment. Make sure you know those things. One other item I want to draw attention to is make sure that you know what a solution to an equation is. It says the solution of an equation with 2 variables consists of 2 numbers, 1 for each variable, that makes the equation true. For example, in ours over here, we found out that if you plug in 4, it gives you 5. So x equals 4 and y equals 5, those are solutions. So x equals 4 and y equals 5. As a pair, as a partnership, those 2 combined, they are a solution to the original equation. And if you're not sure, you can test it. We're going to make y, let's take this y and replace it with 5. So I'm going to write the same thing, but instead of y, I'm going to have a 5. So 5 equals, then we're going to plug in the rest, 2x minus 3. X is changing, minus 3. X is 4, according to our solution. So let's see if it's true. Let's actually check it. So 2 times 4 is 8. 8 minus 3 is 5. So 8 minus 3 is 5, so that means we have 5 equals, okay, there's a 5 over there, 5. 5 equals 5. Is that a true statement? So 5 equals 5 is a true statement. So that means it is. So it means we plugged in our solutions, 4 and 5. This is just like when you were checking your answers with 1 variable equations, when all you had were x or x's. This is just like that, plugging in and checking. So 4 x equals 4 and y equals 5 is a solution to this equation, this function, because we plugged in and checked. That and it was a result of an input-output table. So that always means there's a solution as well. All right, so let's take a look at a different example, okay? In this one, we're going to do number 2. So if you think you can do this one, hit pause and see if you can do it yourself and give it a shot. It says y equals 3/4 x. Normally we would choose these values, okay? But they chose them for us. They did the strategy for us. Notice, this one is 1 through 4. This one is 1 through 4. This one is not 1 through 4. They chose something different. And it's because they're trying to use strategy to help show you if you have 3/4 times x, you don't have to always deal with having fraction answers. You could choose certain answers that will make it a whole number answer. So all these answers will be pretty whole number answers, and you'll see that in just a second. So for all of them, I'm just going to start by writing how the format. So we know it's going to look like that: 3/4 times something. 3/4. Get out of the eraser. 3/4 times something. So it's the same problem, but now you're going to plug in what you chose. We chose 4, 8, 12, 16. I know the paper chose it for us, but in the future you could use this as your strategy to choose for yourself. So 4 goes here, 8 goes here, 12 goes here, and 16. So now to actually decide what these equal. The first one, 3/4 times 4. You could go through the math and actually solve all this and do 3/4 times 4 over 1, which equals 12 over 4. 12 over 4 equals 3. You could go about it doing that way. Or there's a shortcut when doing these. Let me erase that for a second. I'll leave that on the side. Look what we have here. We have divided by 4. Fraction bar 4 means divided by 4. We have times by 4. Well, hey, those are the opposites of each other. Dividing by 4, multiplying by 4, those are the opposites. They're inverse operations, which means, fancy way of saying, they undo each other. Meaning they cancel each other out. So what that really leaves you with is, look, the 4's are gone, and you're left with 3. But isn't that the same thing we just got when we actually calculated it? And so yeah, it is. So to give you a hint in the future, anytime you multiply a fraction, 3/4 or any fraction, by its denominator, you're left with the numerator. That's your answer. So y equals 3 for that one. Some of you may be like, okay, well, if we multiply 4 and equals 3, well, if we multiply by 8, well, 8 is double 4. So this one is going to be double 3. So we already know it's going to be 6, but let's make sure we understand we can prove it. So 3/4 times 8. So okay, let's see. 3/4 times 8, maybe 8 over 1, so we can multiply it. Some of you might remember your shortcut when multiplying fractions, the cross canceling. 4 goes into 8 and 4. 4 goes into itself once, 4 goes into 8 twice. So now we can multiply that. 3 times 2. 3 times 2 is 6. 1 times 1 is 1. There you go, eraser. So 6 over 1, that's equals 6. If you had not used the shortcut, you would have done 3 times 8 is 24. You would have had 24 over 4 times 1, which is 4. 24 over 4 equals 6. So you've gotten the same thing. So it's what we expected. Now for 3/4 times 12. 3/4 times 12, put over 1. Simplify, that's a 1, that's a 3. So we get 9 over 1, which is just 9. So that's going to be a 9. And you'll notice it's going up by 3 each time. Okay? And we knew that because when you multiply by 4, you were left with 3 up here. And since all of these are multiples of 4, all of these will be going up by 3. It's one of those little shortcuts you can remember in the future. If you didn't quite understand what I was just saying, don't stress. It's just a little shortcut. It's a way to handle number operations. The essence I want you to focus on is, even if there's a fraction, it's okay. You do the exact same thing. You still plug in, except you just have to use your fraction skills to see what it equals. And so for this problem, we now have fulfilled our input-output table. And when they said to identify the domain, you would say the domain equals, and I'm going to take a shortcut. Look at that. All of those. The domain equals that. That's kind of being lazy. But you can take time to say 4, 8, 12, 16. That's your domain. And then your range is just going to be the others. So the range is going to be your 3, your 6, your 9, and your 12. Take time to write them out. In the beginning, we want to make sure you can identify which one is which. We want to lock it in for you so you know which one is which. So in this example, we were just using fractions. Now, I'm not going to do number 5 all the way through, but I'm at least going to get you started on it. Is even if there's a decimal, it still works. I just wanted you to be aware of that. So 0.2 and the input's going to be a 1. So 0.2 times 1, well that just equals 0.2. 0.2 times 2, that equals 0.4. My point is, it's still the same. You just have decimal answers. So your domain for this will be 1, 2, 3, 4. Your range will be 0.2, 0.4, 0.6, 0.8. That will be your range, those values. So even if there's decimals, it still works, so don't freak out. All right, let's take a little more complicated examples. Okay, we're going to look at number 7. Some of you will be thinking, well, hey, where's the input-output table? Where'd it go? And you'll be thinking, all right, let's see. It says we're going to make our own if we don't have one. Solve each word problem. Travel. For every gallon of gas, a car can travel 30 miles. Well, I don't know about you, but that's a fancy way of saying 30 miles per gallon. That's a very common unit rate we're used to using. So for every gallon of gas, car travels 30 miles. Write an equation using 2 variables to show the relationship between the distance the car travels and the gallons of gas it uses. So distance and gallons, or gas, those are the items, those are our variables. Those things are changing. It says to show the relationship between the distance and the gallons, okay? So that means those are going to be our x and our y. Those are going to be our inputs and our outputs. It's going to be up for you. It's going to be up to you technically what letters to use, but let's go with the regular old, and let's go ahead and stick with x and y. Now, you choose how many gallons. You choose how many gallons to put in your gas. They don't choose you. You can let go of that handle anytime you want. So because the gallons is the one you choose, how much gas to put in your car, that's going to be your independent variable, which means that's going to be your input. That's the one you choose and you put in. And then the distance is just going to be a result of that. So the gallons is the cause, the distance is just the result. So it's going to be output, which is going to make it the y. Now, 30 miles per gallon, based on gallons, that means 1 gallon goes 30 miles, 3 gallons goes 90 miles, 2 gallons goes 60 miles. You're essentially multiplying. So the miles per gallon and the number of gallons, they have a multiplying relationship, which means 30 miles per gallon times x. 30 miles per gallon times how many gallons we have, that'll tell us how far we go. And remember, how far we go is the distance, which is y. So y equals 30x. That's your equation that models the relationship of miles per gallon. That models gallons relating to distance. Now you can use that to answer any question they ask you. For example, part B. If a car had 8 gallons of gas left in its tank, how many miles can it travel before the tank runs out? Well, if we got 30 miles per gallon, we have 8 gallons. That means, hey, that's like an input-output table. X, 30x is what the function says. What does that mean for y? So if we're plugging in 8 gallons of gas, that means 30 miles times 8 gallons of gas. Well, 8 times 3 is 24. Add a 0, so that's 240. So that means 240. And remember, y was distance. Distance was miles. So that's 240 miles. So that means on 8 gallons, you go 240 miles. I know you could have answered this one without an input-output table, but I wanted to show you can still always make one if they don't give you one. Especially if they ask for multiple values for gallons of gas, for example. What about 8 gallons? What about 12 gallons? What about 23 gallons? Those would just be more entries, more inputs to now come across for each different outputs. So if they don't give you an input-output table, make your own. You get to choose the input value. In this case, for this question, we had to choose 8 because that's what they were asking about. So I hope that this kind of gave you an idea of this whole input-output function relationship stuff. Just remember the stuff we talked about in the beginning. X is usually your input. X is the one you choose. Because it's the one you choose, it is your independent variable. And so it is also going to be your domain. The domain is essentially the independent variable, the X variable items of your function. So if they ask you for domain and range, just list the numbers for now. Now, Y is the opposite, okay? So for input-output tables, I want you to know, plug in the values they give you, just like you've learned with your basic order of operations skills, and just evaluate, see what it equals. Take the time to fill out the entire table, Okay? Take the time to actually check. Don't assume you can do some of them. Take the time to be careful. It's going to force you to remember each of your number sense operations. But just take your time. It is a necessary step because it's going to help you for future tasks.